Okay, once again, I expect you to check solutions. There's a reason why I give you solutions. And every worksheet that you have solutions there. So things that you have trouble figuring out a little bit, that gives you opportunity to be able to maybe look at some solutions and figure it out. Okay, today we start actually getting into some numerical ideas. Start working a little bit more statistics ideas. The blah, 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 the introduction of vocab and things of that sort. We're through that now. So we get to actually start getting into some actual mathematical things. Okay, when we take a look at raw data, we're going to organize our data. Okay, we have to do a collection of the data, and then we want to organize this data. Okay, we collect the data by doing surveys, and we have different methods of doing surveys. But now we collect this raw data in the surveys, and we just write it down. We don't put a name to it. We just collect data. For example, if I was going to do a survey in this room, how many apps do you have on your phone? I would go around to each one of you and ask you how many apps you have on your phone. I wouldn't write down your name. I would just, how many do you have? How many do you have? And I would just write the number down, write the number down, write the number down. I don't care who it is. I just want raw data. I just want the data values. Okay, so raw data is collection of data in the original form. That's just listing numbers. I have 7, I have 9, I have 12, I have 15, I have 4. Okay, I just write it down in the original form. Frequency distribution, organizations of data. This is driving me nuts. You guys keep on getting closer and closer to me. I'm just trying to stay out of your way. Stay out of your way so you can copy notes, but I have no place to go. You guys keep on, it's like, keep on coming closer and closer and closer to me. It's like a mind sweep game or something like that. The next line, Tetris here. Yeah. The next line is just coming closer and closer to me. Okay. Organization of data in classes with corresponding tallies and totaling of the numbers of times scores occur in the class. And once again, please do offer me grace because I am a math teacher. I sometimes may misspell a word. I may sometimes not use grammatically correct sentences up here. I'm sorry. I apologize. Okay? I teach math. Classes, there are quantitative or qualitative categories. Okay, a class, you have a class there. It's either going to be quantitative or qualitative of the classes. What month were you born in? And I go through the category, go through the room and ask you what month you're born in. And I would tally up whatever month that you were born in. Once again, I would not care about who it is. Yes, I care about you. I care about you. But in regards to raw data, I don't really care who you are. I just tally up and collect the data. I care about all of you. Frequency. The frequency. It's the number of times. The number of times data values occur in a class. The number of times data values occur in a class. See, I work well with things that give you red squiggles underneath. Red squiggles underneath help me out a lot. Then I can right click and autocorrect it. So how many times something occurs? We have upper limits. The upper limit for the data value and the smaller limit. Okay, we're going to talk about a couple types of limits here. We're going to talk about the data value limits, which is your biggest value. What's the biggest number we have? The lower limit of the data is the smallest value. Okay, it's sort of a common sense thing. But you have upper and lower limits for the data values. Biggest value, smallest value. We have the range. And this is over all your data values. What's your biggest value and what's your smallest value for all the data values. We have the range of values. It's your upper limit minus your lower limit. That's your range of values. Now your class width. You have to develop a class width. I'm not going to tell you you're going to make 5 classes, all have a class width of 7 or 10 or anything of that sort. You need to develop that. You need to develop the class width. Well, how do you determine a class width? You take your range of values, your upper limit minus your lower limit. You take your range of values that you can calculate here and divide by the total number of classes. How many classes do you want? Do you want 8 classes? Do you want 10 classes? Do you want 5 classes? But once again, this is where it starts to vary a little bit with traditional mathematics that you're used to. Okay, you divide these two values, then you round up to the next biggest integer. So if you do this class width and you come down to 9.2, traditionally in the math world, we have always been taught to round that down to 9. We always go up. So we go up to 10. If you go down to 9, what will happen if you go down to 9? You won't be able to fit all your data values in classes. So you go up to the next biggest value. So how do we deal with how do we make a frequency table? Okay, there's a process to go through. The lower limit of the first class can be the lower limit of the data values or one below that. Okay, you can either go one below that, or if you go one below and you do not get all your data values in classes, you're going to have to erase things out and redo it. But traditionally, if you just go 1 unit below or just the lower limit of the data values, what is your lower limit? That's your lower limit of your first class. Okay, this is of the class, and this is of all data. Okay, so there's 2 different limit ideas here. You have data values, lower limit, and then you have the classes that you're going to deal with in your frequency table, the lower limit. Lower limit of the first class can be the lower limit of the data values or 1 unit below that. The lower limit of the next class, this is the first thing you set. This is the first thing you set. You go to this one next. The lower limit of the next class, of the next classes, can be found by adding the class width to the previous lower limit. So you take your lower limit you add your class width. You take the lower limit of the previous value, class, you add your class width to get your lower limit of the next class. Okay, you don't go to your upper limits yet. Okay, you go lower limit, lower limit. Then you look at the upper limit of a class is one less than the lower limit of the next class. And we'll go through an example here. You'll see there's a lot of verbiage here, but you'll see that it's not as difficult as what you see here. The upper limit of a class is one less than the lower limit of the next class. These are limits. Then we have our class boundaries. They are half unit bigger than the upper limit of a class and half unit smaller than the lower limit of the class. The class width is the upper limit boundary minus your lower limit boundary. Okay, or your upper class boundary and lower class boundary. So these class boundaries here, I could subtract here to find my class width. And once again, we'll go through a problem here in a minute. Relative frequency. Relative frequency is the percent of scores. What is the percent of scores in each class? When you talk about a relative concept, you talk about percentages of. Okay, we're going to take a look at Barry Bonds' home run total by season. Barry Bonds is the disputed home run king of Major League Baseball. Okay? He hit the most home runs than anybody else did in Major League Baseball careers. It's disputed because Barry Bonds, they say, was juiced up. Okay? Stand up, Jace. Stand up. When Barry Bonds entered the Major League Baseball as a center fielder for the Pittsburgh Pirates, there he is. What? I mean, he was built like you, maybe a little bit more muscle, but not much, because he was 22, 23 years old. Okay, you're only 16 years old, 17 years old. Okay, he developed some muscle. Okay, go ahead, sit down. Okay, but that's what Barry Bonds looked like when he entered Major League Baseball, maybe a little bit more muscle. Okay? When Barry Bonds retired, he didn't look like that. Okay? He didn't look like that. It's disputed because he said he was on steroids. Okay, now, history lesson. Okay, what steroids are used for? Okay, there's a lot of you that get put on steroids. If you have a major reaction to poison ivy, and your face starts breaking out poison ivy, and you have poison ivy all over your body, and you have bad reaction, and you go to the doctor, what they're going to put you on is they're going to put you on a pack of steroids. Now, if you've ever had problems with poison ivy, they start you with 10, then the next day you take 9, then the next day you take 8, then you take 7, then you take 6 and 5, and you step yourself down off of that. They put you on a steroid. Okay? It's used to heal bodies. Okay? Muscles, injuries. It is a huge thing in regards to the healing of injuries for athletes or for anybody regular, us people. We could get put on a steroid to heal our bodies. Okay? If you have a sprain or if you have something like, you can be put on a steroid. Okay? They're doing steroids. Doctors were prescribing steroids to athletes when they were injured. They had no idea what they were dealing with in regards to what those steroids would do. Then all of a sudden, somebody found out, well, if I start lifting some weights while I'm on steroids, man, I'm getting more muscles. I'm getting stronger. Because they wanted their body to get stronger to, if you have knee issues, I want to strengthen my legs, my muscles here, and my muscles here to keep my knee in place. If you don't have very strong muscle structure in these, this is why people that are 14 years old, 13, 12 years old have ACL problems. Okay? They have ACL problems. The reason why? Your muscles have not developed in your legs enough to keep your knee where it needs to be. Okay? So you have issues there. Okay? That's why you have ACL problems to younger ages. But it was used to heal people. They found that all of a sudden, if I'm doing muscles, I get stronger. Well, I'm going to stay on the steroids because I'm going to lift muscle. I'm going to lift weights and get stronger. I can hit the ball farther. There's no rules against this. Baseball had no rules against steroids. How many baseball players were on steroids at that point? A lot. There was a lot. And there's no rules against it. So why are you penalizing Barry Bonds? Because there was no rules against it. Okay? That's like, okay, you have no rectangles out there on the interstate, which means you can drive as fast as you want. There's no speed limits. You're going down 30 out here, going 85 miles an hour. Cop pulls you over and says, you're going too fast. And you go, why? There's no speed limits here. Well, it's against the rules. You're going 85. You have no rules against it. Baseball had no rules against steroids. Any sports did not have any rules against steroids. So that is the Barry Bonds argument in regards to why am I not honored as a person as the home run king? If there's no rules, what am I breaking? Okay, I'm just playing the double advocates in regards to was he juiced up? Did he have an advantage over Babe Ruth? Yeah, Babe Ruth. He didn't lift weight. The only weights he lifted was a few beverages down at the corner and some burgers that he had and big old stogies. Okay, that was his weight training. Barry Bonds had a little bit of advantage over them. Okay, Hank Aaron, same thing. Person they beat, Hank Aaron. Hank Aaron, there was very little weightlifting done back in the 1970s. Okay, so he had an advantage. Yes, he had an advantage. Okay, was he juiced up? Yes, he was juiced up. I think he would admit to that. He doesn't want to quite admit to it, but in a roundabout way, he has said it. But once again, he goes back to what was the rules. Now there are rules against it. Now you have problems and issues if you're on them. So that's Barry Bonds. He was a home run king with an asterisk beside his name. Okay, we are going to do a frequency diagram. The Barry Bonds home run totals. Okay, this is the home run totals he had through the season. This is first season, second season, third season, fourth season, so on. This is just the raw data. We want a total of 7 classes here. So the first thing we have to deal with is we have to deal with the class width. Okay, so we take and look at the biggest value. His biggest value was 73. And his smallest value is a value of 5. Okay? So to find the class width, we go big minus small divided by the total number of values. So our class width is equal to big minus small, our range, divided by our total number of classes. We have 7 classes. Like I said, mathematics is not going to ooh and ah you at all in this class. So I take 73 minus 5, and I divide that by 7. Calista, what do you get? I'm sorry, what? 9.7. Okay? And we take that up to the next biggest integer, which is 10. Okay, so this is our class width as a value of 10. Now, we can either start with our smallest data value or go one less than that. I'm going to go one less than that today for our first class limit. So I'm going to start at 4 with my first class limit. Okay, that's step 1. Lower limit, the first class can be the lower limit of the data values or 1 unit below that. If you want to go 2 might not, your data values might not fit in at that. Okay, the second step, the lower limit of the next class can be found by adding the class width to the previous lower limit. So here is my lower limit of the first class, my lower limit of my next class. I add my class width to it, the value to a value of 14. Step 3, the upper limit of a class is 1 less than the lower limit of the next class. So if I'm at 14 here, my upper limit here is 1 less than that to give me a value of 13. Now, you might sit there and say, well, if I go 13 minus 4, that's only a value of 9. You're correct. It is a value of 9. But just count how many home runs can go in this first class. I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 10 different home runs can go into that class. To get my next class limit, I add my class width to it to give me 24. Then my upper class limit here would then be 1 less than that, 23. So you keep working yourself down. Now, as you can see, to go from here to here, I'm also adding 10. To go to here, I'm also adding 10. So I can add 10 down my column there to give me 34. Add 10 to give me 33. And we can keep on adding 10s. Go ahead and finish it out. And then my last one, once again, I can just add 10. And once again, that's a confusing thing for students because they go, well, 13 minus 4 is 9. Yeah, you're correct. But 4 is an element that could be there. Now, the class boundaries is a half unit bigger than the upper limit and a half unit smaller than the lower limit. So if I look at my class limits here to get my class boundaries, I go a half unit smaller than 3.5 and a half unit bigger than. So I have 3.5 to 13.5. And I can do that throughout the rest. So I go half unit smaller, half unit bigger. And you'll notice you have your tens also going down the column. Now, if you subtract your two class limits, then you get your class width of 10. 13.5 minus 3.5, I get 10. 23.5 minus 13.5, I get 10. Now, if we take a look here, my class boundaries, another confusing part for students is, well, my class boundaries, well, I have to tally with my data values. I got two 13.5s. I got two 33.5s. I got double of everything. What if I have a data value that's 13.5? Which one do I put it into? Well, that's where it goes back to, what are we talking about here? We're talking about numbers of home runs. Your class boundaries we talked about is a half unit more or less than your raw data. 13.5. Has anybody here hit a half of a home run?
No.
In a baseball or a softball game? Well, I hit a double. Does that count as half of a home run if I hit a double?
No.
Well, if I hit two doubles, does that mean I get a home run?
No.
Oh, come on. That's why. We go half bigger and smaller of our raw data. Okay? The next thing we do, we start tallying up. Uh, 16. Which group am I in here? 16, well, I'm in this group right here. Make sure you cross it out. 25, which group am I in? Tally it up. Okay, so tally up each of your elements. Make sure you cross out so you don't do a value twice. I put an extra class in there, didn't I?
Yes, you did, and I was wondering about that.
My bad. Can't be perfect all the time. I try.
Okay.
And your frequencies, your total number, just count up your tallies. Okay, your relative frequency is the percent of scores in each class. Well, we have a total here of 21 seasons. One of these 21 is in the first category. 2 of the 21 is in the second category. 7 of the 21, and 6 of the 21, 4 of the 21, 0 of the 21, and 1 of the 21 are in the rest of the categories. Well, what can we do numerically to take a fraction and make it a percent? Anna?
Well, you would divide it out, and then you would shift the decimal over 2 to the right.
So you're multiplying by what?
100.
Multiply by 100. Go to one decimal place, is fine. So you divide 1 divided by 21, and then multiply by 100, and that will give you a percent.
4.7?
Just go ahead and finish out the rest of your percents.
And we don't round in here, right? You just cut them off.
No, you can round these. You can round these.
Because it's 4.76 then.
So that would be 4.8.
Yeah.
All right. Once again, mathematically, this class is not an ooh and ah class. Or, what did he just do? We're not taking inverse tangent of square root of 3 over 3 and figuring out an angle value.
Ugh.
Alex Cross, what do you have? The rest of them, just read down your column.
4.8, 9.5, 33, 28 or 29, 19, 4.8. 28,
Just 20%, no decimal.
29, just round up.
I want to nearest 10.
28.5, 19. Is it really? Then 0 and 4.8.
It's 19.0.
Um,
What's 4 divided by 21?
19.04.
Okay, 19%. There we go. And once again, if you're off by decimal point, don't worry about this. Don't worry about a penny that you may be off here a little bit. Not a big deal. Histogram. When we deal with a histogram, it's a graph of vertical bars of various heights to represent the frequencies in each class. Okay, a graph of vertical bars of various heights to represent the frequencies of the classes. It's a bar graph. Okay, you may have done this before, a bar graph. you may have done a frequency table before, which is what we just did. But it was more laid out for you in regards to here's your class limits and here's the values that you have. Okay, now you're formulating those class limits. We have a cumulative frequency. A cumulative frequency. It's the number of scores at or below a class. The number of scores at a class or below a class. And a relative, once again, when we talk about relative cumulative frequency, it's the percent of scores at or below a class. So if we take a look at the cumulative frequency, okay, here's my class. This should be class bound, yes, class boundaries here. Okay, here's my frequency. The number of scores that are at this class are below. When I talk about below, smaller than the class. We have one that's at this class. You have no classes below that. But if we take a look at our second class, we have two here. There's two at this class, but there's one value that's smaller than this. So our cumulative frequency would be a value of 3. 2 plus 1, which is a value of 3. My cumulative frequency here, I have 7 at this class, but then I get 3 that are smaller than this, so we have a total of 10. Go ahead and finish that out. And then the relative cumulative frequency, you just change them into a percent. Okay, the worksheet I'm handing out. Just work on the 2 frequency tables that are there. Okay, the things that we worked on in this class up till now, we will continue. This will be a continuous worksheet for us. So continue to work. Just work on the tables, frequency tables. Okay, we'll go over more stuff on Monday. Adios. Have a good weekend. Just do the frequency tables. You have 2 of them there.
Not bad. Number work today.
No, okay, well, let me ask. I'm in that. I have to pee. Like, you destroy everything you gain. Everything you work so hard to get. You destroy it.
Gave it a go anyways. I don't know, would you have done it?
At lunch. So we're sitting in there, his Hannah, periods. Started asking me about sisters homework.
And I was like, I haven't taken this class for the sophomore year. Yeah. Like, what? I made a mistake. I was wondering about that.
I don't know.
Did you watch any of those videos yet?
It's just not, it's like going to being that fun enough. It's not fun.
So you figured you already know the ending, but like, and I know about Bull Riders, about clown.
I turned it off for a while. Like, I mean, now it's fine. It's just
Is she been followed? Is she been followed? Okay. Guys, let's go. Is she been followed?
What's happening?
And now allow me to go.
I could just go home. And I can't drop it without taking it. I don't know. You can't.